In this problem, we're told that between 2005 and 2010, the average rate of inflation is about 3% per year. We're assuming a cart of groceries cost $100 in 2005 and that the rate of inflation remains constant, and then we're asked to answer a few questions about the cost. Now, since the cost is growing due to inflation of 3% per year, that means its growth rate is proportional to its current value. So we'll be using an exponential function c0 e to the kt to denote the cost at time t. The cost, and t we're going to let represent the number of years after 2005. So t years after 2005. So with that choice of the t variable, then we see immediately this constant c0 is the cost in 2005. Because if we plug in 0 for t, then you get c0 e to the 0 power, e to the 0 is 1, and then you get that constant that we were calling c0. And the problem tells us that c0 is equal to 100. Now, the interesting thing about exponential functions is that their growth rate, which is found by taking the derivative using the chain rule, we get k times c0 e to the kt, and this is the same as k times c of t, the cost function. So the growth rate is proportional to the current cost. C prime equals k times c. It often is useful to think about the relative growth rate, which we obtain by taking c prime and just dividing it by c of t. And the formula then is c0 e to the kt. Forgot the k in the derivative, and then we divide by c0 e to the kt. The c0's cancel, the exponentials cancel, and we're just left with the k. This gives us another way of thinking about exponential growth. The relative growth rate is a constant k. And many students often confuse k with this 3% inflation rate, but you have to be very careful here. There is a relationship between this 3% and this k, but they are not going to be equal to each other. So let's figure out what k is. And to find k, just think about what happens over the course of a single year. So if we were to plug in c of 1, then by definition that's c0 e to the kt, but I'm plugging in t equals 1. So just change that to a 1. So I get c0 e to the k. And that's also, we know that c0 is the same as c of 0, so that's c of 0 e to the k. Now, what about this inflation rate of 3% per year? Well, going from t equals 0 to t equals 1, the cost is going to increase by 3%. So on the other hand, t of 1 is 100% plus 3% multiplied by c of 0, the beginning of the year, the cost at the beginning of the year. And as a decimal, this is 1.03 c of 0. So we get this two equivalent expressions for the cost at the end of the first year. C of 0 e to the k equals 1.03 c of 0. And you see that the costs cancel, and we're just left with the equation e to the k equals 1.03. So by taking natural logs, we have k is natural log of 1.03. This allows us to rewrite our exponential function. C of t is c0. We already know that's 100 in this problem. Then we have e to the k, which is natural log of 1.03 times t. And now anytime you have something being multiplied by natural log, in this case t, we can bring t inside of the natural log function and it becomes an exponent. So we'll have e to the natural log of 1.03 to the t power. And I did this because I want to get e to the natural log of something. The exponential function e to the x and the natural log of x are inverse functions of each other. So this simplifies as 100 times 1.03 to the t power. So this is an equivalent way of writing our exponential growth function for the cost. 100 times the t power of 1.03. So now we can start answering some of these questions. For example, what will the cost be in 2015? So we have to plug in something for t. Now, not 2015, but remember t, it represents the number of years after 2005. So we're going to plug in the number of years after 2005. So we have to take the difference, 2015, and subtract 2005, and of course that's 10 years. So we have 100 times 1.03 to the 10th power. So I'll pull up a calculator, have 100 times 1.03 to the 10th power, and we see that's about $134.39. So it's about $134.39. So that's our cost of this grocery cart in 2015. Now, the doubling time is the time it takes for the cost to double. And so let's now find the doubling time. Well, the doubling time is going to be expressed as 2 times the original cost, and let's call the doubling time capital T. It's the time it takes for the cost to double. So it's going to be C of capital T, and when we plug capital T into our expression, this is going to be 100 times 1.03 to the capital T power. And so we solve this equation. Remember, this 100 is the initial cost at 2005, so C of 0 is 100, and that equals 100 times 1.03 to the t power. The hundreds cancel, and we have 2 equals 1.03 time to the doubling time power, capital T. We have to solve for t. It's in an exponent, so we're going to take the natural log of both sides. And using that property of exponents, we can bring the t outside of the natural log, so we have the doubling time t is the natural log of 2 divided by the natural log of 1.03. And using our calculator, we're going to have the natural log of 2 divided by the natural log of 1.03. It's about 23.45 years. So we have, it's about 23.45 years. Okay, and finally, we're going to answer how long it takes to add 75% to the original cost. So we want to solve for the time t when the cost has added 75% to the original cost. Well, that's the same as multiplying the original cost by 1.75. Okay, so that's 1.75 times 100, and our formula again for C of t is 100 times 1.03 to the t power. So we want to know when that's equal to 1.75 times 100. The 100s cancel from both sides, and then we're just solving 1.75 equals 1.03 to the t power. Again, taking the natural log of both sides. We have natural log of 1.03 to the t power equals natural log of 1.75. The t comes out, again by property of natural logs. So now we can just divide by natural log of 1.03 to get t equals natural log 1.75 divided by the natural log of 1.03. And we'll plug this into the calculator and we'll get a good approximation. Natural log 1.75 divided by natural log of 1.03, and we see our answer is about 18.93 years. So 18.93 years. That's how long it takes to add 75% to the original cost.